Hello, it is Mr. E. How are you guys doing? It's good to see you guys virtually anyway. You can always join in on our Zoom. That way we can get some face-to-face conversations going. But we're going to go ahead and take a look at our lesson today for Math 8. Okay, for Math 8 today, we are talking about solving equations using combining like terms. Okay, so yesterday we talked about solving two-step equations, right? And so today we're going to talk about what do you do if there's terms that you need to combine first. Okay, so we're going to take a look at that. Hopefully you can see the screen here. And let's have at it. Okay, I'm going to be moving kind of quick today. If you need to pause the video or slow it down, feel free to, okay? That's the nice thing about having this recorded is you can repeat it and you can ask questions on it as well. Okay, so I'm just going to go right into this, and if you need to repeat any part, you can. All right, so defining terms. Okay, if we're talking about terms, any term is a number separated by an addition symbol or a subtraction symbol. Okay, so we've got two terms here, right? We've got a 4p term, a 2p term, a 6. Here we've got 1, 2, 3, 4 terms, right? 4 terms, because they're separated each by subtracting or adding, okay? If we are now combining like terms, that's like saying we are combining terms that are the same. That's what we're doing. So here we've got a number term, I'll call it, okay? Numeric term, we've got a p term and a p term. So are any of these like terms? Well, we've got 2 p terms and 1 non-p term. So I can combine the terms that are like these two guys. 4p plus 2p is going to be 6p. Okay, and then the 6 just comes down. All right, and then from there, we could solve that one-step equation, right? We'd get p is equal to 1 by dividing both sides by 6. But even not worrying about solving, okay, let's scratch that. Not even worrying about solving is we're combining those two terms that are like terms, right? Same over here. Do we see any like terms? Well, there's an m term here. There's an m term here. There's 6 of them, but there's an m term here. There is a number term right here, and there's a number term here. So a positive 1m and a positive, that's what the plus means, positive 6m. 1m plus 6m. That's going to be 7m, isn't it? So that's going to be 7m. And then over here, we have to be careful here, because this is not just minus 7, it's a negative 7. Means the same thing, but we have to take that negative with it. So if we have negative 7, and we have a positive 6, that's like saying take 7 away, right? Negative 7. Take 7 away from positive 6. Okay, so if I take 6 away from 6, that takes us to 0, right? So I take 1 more than that, it's going to take us to negative 1. Negative 1. Okay, so we'd have 7m minus 1 if we were simplifying. Okay, so whether it's an equation or it's an expression, there's 3 terms there. One of them separated by the equal sign, and this one has no equal sign, and it just has 4 terms being combined. Okay, and we've said these two are like terms and these two are like terms, right? Let's draw that. These two are like terms. All right, so how's it going to look like if we are combining terms? Again, this is just another practice before we go into solving equations with it. So we'll pause this for a sec. All right, so let's see what we get here. We've got an m term, and I would, either on your paper or on your slideshow, I would go ahead and highlight these or underline these like we're doing as well. Okay, it's good practice, and it makes it easy to see what's going on. So we've got 2 m terms, and we've got a numeric term, integer, and an integer here. These are both the same types of terms. They're just numbers, right? And these are m terms. So let's combine like terms, terms that are the same, that are like each other. So we've got a positive 1m and a positive 6m. Add those two, we get a 7m, right? Good. So then now we come over here and we say negative 7 and a positive 6. Okay, we're going to get a -1. Okay, and we don't have to put a plus there, so we can just use that -1 as a subtraction symbol. So that's what we just did up there, right? Just same thing, trying it yourself if you want to do that on your sheet as well. Okay, all right. So, and we already did this one as well. Okay, we did that over here where we said 6p plus 2p equals 6. Let's do that again real quick and just solve it this time. 4p plus 2p is 6p equal to 6. And now this is a one-step equation. How do I know that? Because there's only one term over here, and it's got our p. So we could say, all right, how do I solve this? Inverse operations, right? That's what we talked about yesterday. Opposite of multiplying by 6 would be dividing by 6. And whatever I do to one side, I have to do to the other, right? So we've got 6 over 6, which makes one whole. And so now we have p is equal to 1, right? And we can always check our answers. The nice thing about equations, plug it back in to the original equation to see if you got it right. Okay, so if these were 1s instead, 4 times 1 is 4, 2 times 1 is 2, so then it would say 4 plus 2 is equal to 6. Is that true? Yeah, that's true. So we know that we got it correct. Ding. Okay. All right, so now your turn, okay? I want you to try to solve this equation by combining like terms, okay? Find this on your sheet. You can do it on paper or on your slides. Go and pause the video and see if you guys got it correct. All right, let's see if you guys got it. So we've got 3 terms here, a 5x, a 2x, and a negative 21. So we've got 2x terms and a numeric term. So if we have these 2 x terms, guess what? They are like terms, so we want to combine them before we can solve, because otherwise we're solving for 2 x's, and we want to solve for just 1. So 5x plus 2x, okay, will then become 7x, okay, and we've got the negative 21 still there on the right. Now it's a one-step equation. How do we solve for x? How do we get rid of a multiplying by 7? Well, opposite of multiplying by 7, or the inverse of multiplying by 7, is dividing by 7. So we have to divide by 7 on the left side and divide by 7 on the right side to keep it balanced as an equation. And so now once we do that, 7 over 7 is just one whole, isn't it? So then that's just 1x. So we just have x equals, and then 21 divided by 7 is 3, and a negative divided by a positive, it's an odd number of negative terms. Our answer is going to be a -3. Okay, so there's our solution. We can always plug that -3 back into the start, into these two guys, to see if it makes a true statement. Okay, so if I did 3 times 15, that's, 3 times 5, that's 15, -15. And -3 times 2 would be -6. So I'd get -15 plus -6 equals -21. Is that true? Yes, it looks like it is, right? 15 plus 6 is 21. All right, moving on. So let's look at another one together. If we have one that has a couple more terms in it, let's see, we've got, how many of each type of term do we have? That's what we want to ask. Well, maybe I'll use highlight on this one to mix things up. So I've got what looks like a number term here, right? A -2. I've got another number term here, a -7. and a 21 over here. Okay, and then I've got a k term over here. So that makes it really nice and easy to see, right? We've got these three are all like terms, and this one is not. So we need to combine any terms that we can before we start solving, right? So let's say -2 plus -7, or if you want to say -2 minus 7, go back 7. Either way, you're going to get, you got 2 negatives and 7 negatives. Now you have 9, excuse me. Now you have 9 negatives, right? So we've got -9 from those two combining. We've got our -6x, our -6k over here still. And we have 21 over here. Okay, now if we're going to solve for k, if we're going to isolate a variable, now it's a two-step equation, just like you've done before. So we say, okay, no big deal. What's the opposite of subtracting 9? I'm going to start with the 9 because it's not as close to the k. It's not as tied up. So what's the opposite of subtracting 9? It's going to be adding 9. So plus 9 to both sides to keep it equal. -9 plus 9 is then going to be 0, right? Those cancel. So now we should have -6k equals 30. Okay, -6k equals 30, and now it's a one-step equation. So we say, all right, opposite of multiplying by -6 would then be dividing by -6. So we could say, okay, divide by -6, divide by -6. And -6 over -6 as a fraction, that's just one whole again, isn't it? That's the reason that we do that. Okay, we divide, we do the inverse operation on this, so that way it will just become a 1. So now we have k is equal to 30 divided by 6 is 5, right? And a positive term divided by a negative term is a negative, because there's a negative number of terms. There's only one out of the two terms that are negative. All right, so we have k is equal to -5. That's our answer. We could plug it back in, of course, if we need to. -5 times -6 is 30. 30 minus 2 minus 7. Okay, well, 30 minus 2 is 28. Minus 7 more is 21. Oh, we got it right. Da-da-da. We checked it. We know it's correct. All right, so now it's your turn. I want you to try a similar problem by yourself. Pause the video here and see what you get. All right, let's see what we get here. Hopefully you got the same thing to start as this. I actually didn't do this one all the way through first because I wanted you guys to kind of see what we did. So we've got 3 terms that are all like terms. Those are all constants. You see I wrote 5, 2, and -1 are the constants. And that's another way of saying those numeric terms, right? Constants. And then this one is a variable, the -8m, because it's got m in it. All right, so if we're going to solve, we need to combine those terms that we can first. 5 and a positive 2 would make 7, right? So I'm going to say 7 here. Positive 7. I'm going to leave that -8m alone. It's not very good 8, is it? -8m. And the -1 I can't really mess with yet because it's on the other side. But now we need to start solving for m. Okay, so we say our first step, well, let's get m by itself. We want to isolate this variable to solve, right? So we have to do the inverse operations, the opposite of adding 7, subtracting 7. Hopefully you did that. I'm going to move really quick because you're just checking your work here. These cancel out, right, to 0, so you should have -8m Equal sign is still there, of course. And -1 minus 7 should be -8. Okay, and to solve for m, this is -8 times m, so we have to divide by -8, divide by -8, and that's going to cancel out to be 1 whole, so we should get m is equal to, and this side cancels out as well, -8 over -8, that's 1 whole, isn't it? So m equals 1. Okay, if you don't believe me, that is okay. You can check in your expression or your equation up here at the top. Plug it in. 1 times -8 is going to be -8. So then you have 5 minus 8 is -3. Plus 2 is going to be -1. So we got it correct. We know for a fact that we've got it correct. Easy to check these. All right. So we've got 2 more we're going to do here. We'll see if we can do them together. Okay. All right. Let's see what our like terms are first. We've got a v term here. Got a v term here. Looks like I've got a number term here, numeric term or a constant, and another constant here. Those are my like terms, so I better combine them if I can. 7v and a v. Let's see, that's going to make 8v. Okay, plus 7 equals -1. Fix that. Equals -1. Okay, so now that looks like a 2-step equation to me. I don't know about, does it look like it to you? Hopefully so. So we say, all right, sweet, now we can just solve. Opposite of adding 7, subtracting 7. Whatever I do to one side to an equation, I have to do to the other, right? So divide, not divide, subtract 7 from both sides. 7 minus 7 is 0. We got 0 over here. And then an 8v is left over. We didn't touch that. Equal sign drops down. -1 minus 7. It's going to be 7 further into the negatives, right? So it should be at a -8. Okay, now to solve for v, to get v by itself, okay, I need to do the inverse operation. If they're multiplying 8 times v, then I need to do the opposite, which is dividing. Okay. So if we're multiplying v times 8, opposite of multiplying 8 is going to be dividing by 8. Let's do that to both sides. That's 1 whole. And now v is equal to -1. Okay? You always plug it in to see if you got your answer correct. Excuse me. So now I want you to take this problem, pause the video again, try it on your own, and then come back and see if you got the right answer. All right, let's see if this is how you set yours up. Noticing that these are the variables, 8x and -2x, and these are the constants, the -8 and the 88. All right, let's see if we got our answer right. 8x minus 2x, right? Or 8x and a -2x. That's like saying take 2 x's away from the 8x, right? So that's going to be 6x, right? So we're going to say, draw it down here, 6x is equal to, sorry, not equal to, 6x, we still have our -8, 6x minus 8, or -8, equals 88. Okay, now it's a 2-step equation. So if we're going to solve, we need to start with the one furthest away from the x. That's usually going to be the easiest one anyway. So let's say plus 8. Add 8 to this side, and whatever I do to one side, I have to do to the other, right? So add 8 to -8, that's going to make 0. So now we have 6x plus 0, which doesn't do anything, so it's just 6x equals 88 plus 8, that's going to be 96, right? 96. And now to get x by itself, we're going to divide both sides by 6. Divide by 6, divide by 6. So 6 over 6 is 1 whole, so that's going to be x is equal to 96 divided by 6. And I want to double check myself, so I can always, no shame in double checking, maybe 16. So we say, all right, 16, that is my solution. And I can always plug it back into the original problem to see if I got it right. Okay, all right, and last example together. See if we can do this one a little bit trickier, right? Just each time getting a little bit trickier. So let's mark this thing up. I've got an x term here. I've got an x term here. I've got number term here. Number term here. Number term here. And number term here. Again, I'm saying number term, numeric term, constant. These are all the same thing. Okay, so the yellows are all like terms, and the greens are like terms as well to each other, right? So let's go ahead and try and combine some of these first. Well, let's see. I've got 12, take away 7, add 2. Well, I can do that, right? What is 12 take away 7? So if we say 12 take away 7, that's going to be, let's see, take away 2 would be 10, right? And so take away 5 more would get us to 5, right? If you were thinking 5, that's correct. So then we now have 5, and then add 2 to that would get us back to 7. Okay, so we have a 7 over here, equal sign over here, 32 over here. All right, and then we have our 4x and our 9x here. It's a negative 9x though. So what would I do if I had 4 x's and I took away 9 of them? Well, if I took away 9 of them, I'd take away 4. That would get us to 0. And then I have to take 5 more than that. So it's going to be 5 in the negatives, right? Or this way. 5 in the negatives. So let's say negative 5x. I've got a negative 5x and I've got a positive 7. What do I use for positive? Well, a plus sign. So negative 5x positive 7, or negative 5x plus 7 equals 32. Okay, if I need to pull those together, let's see if I can do this. Aha, okay. So now I just go ahead and solve two-step equation. Opposite of adding 7 would be subtracting 7. Do that to both sides. 7 minus 7 is 0. So now I have negative 5x equal to, see, take away 2 would make it to 30, and then 5 more would make it 25. And the last step would be to divide both sides, right, because these are multiplying, would be to do the inverse, the opposite. Divide both sides. What are we going to divide by? Whatever this is, right? So divided by negative 5 on both sides. That way, those would cancel out. Negative 5 over negative 5 is going to be 1. So now it's just 1x equals 25 divided by 5 is 5, and a positive divided by a negative is a negative, because we have an odd number of negative terms. So there's our answer. X equals negative 5, and I could always plug it back in, right? I could plug it back into these x's, multiply, and see if I get a true statement up here. Okay, if you do, you know that you got it correct. All right, one last time, I want you guys to try this one, this tricky one, by yourselves, and see if you guys got it, all right? I know that's a lot of work, a lot of practice. Let's see if you guys have it figured out, and then we'll be able to check. Okay, so pause the video and see. All right, guys, let's see if you got it. So we have 4x plus 2x minus 3x. So that's going to make 6x, and then take away 3x. That's going to be back to 3x. We've got 22, take away 6, add 2. So that's going to be 22 take away 6 is going to be 16, right? And then add 2 is going to make it to 18. And then the equal comes down, 63 comes down. We didn't touch those. Now it's a two-step equation. Okay, so we say opposite of adding 18, subtracting 18, right? So subtracting 18 from both sides is going to cancel these out so that there's nothing left, right? And so now we have a 3x left on the left-hand side. And on the right-hand side, 63 minus 18. Let's see what we get there. 63 minus 10 would be 53. Okay, 53, and then minus 8 more. So we would get to 50 if we took 3 more, and then 5 more. 45, right? So we get 45. Get out of here. Get out of my face. Advertisement. Okay, so we have 3x equals 45. And now we're a one-step equation, so divide by 3. Divide by 3. That's going to make one whole, right? So we have x equal to 45 divided by 3 is 15. Is that what you got? Hopefully that's the answer that you got. You can always plug it back into each of those variables and see if it gives you a true statement. If it does, you know you're correct. Okay, so now comes the time that each person takes their own path. So we're going to do an IXL practice, just one set right here for part of our grade, and then we're going to, if you feel comfortable on that, you get to the to 90. Then you're going to go ahead and take the quizzes and ace that. Okay, if you do these and make sure you get them to the score that I'm suggesting to you guys, like 90 in this case, then you'll do fantastic on the quizzes. You'll do really well. Okay, so if you haven't already, so that IXL, if you click on it, it takes you to W10, 8th grade W10. Remember, yesterday's was in 7th grade, just because it was a little bit of review. But today, W10, that's the set that you're going to be doing. And get it to 90 SMART score. Okay, 90 SMART score. The last thing is, if you haven't seen the info page already, make sure you head over there. I'll post it in this post as well. But the link takes you to a page here, and it tells you how the online class works. We got IXLs, a few CFAs, quizzes. Those will make up your grades for the most part, unless otherwise stated. And then we have our classroom code, information about Zoom, Instagram account if you want some funny content from the math department, and then link to my YouTube and the agenda for each day. Okay, so you'll see what the lesson is and what the assignment is on the right-hand side. Okay, all right. Well, have at it, guys. Do your best, and I wish you all luck.